Hi, we'll discuss visual encoding method and selecting appropriate visual encoding while preparing visual or presentation or graphs. What is visual encoding? Visual encoding is use of visual element of the graphs to represent data in a way it can be easily understood and interpreted by the human eye or the reader. It involves the process of translating data values, the magnitude into visual properties such as position, size, shape, color, and orientation. So we are trying to map the data value into these properties of visual presentations. Designing data visualization, choosing correct visual encoding method on which we are going to encode the magnitude of the data among the various visual property is depends on type of data and what kind of message we are trying to convey, whether we want to do comparative presentation or simply the numerical value presentation, all those things. For example, if you are having quantitative data, you can use positional, length, angle, and area properties of the visual to represent the data value. Suppose you are involving categorical data, color value, the hue of color, texture, shape, and orientations can be used to represent the magnitude of the data of categorical type. Suppose you are interested to prepare a visualization for highlighting something. You can use variation in the color using saturation and lightness, and you can use size property to present effectively the highlighting information. So selecting or choosing appropriate visual encoding method. Position. It is best for quantitative comparison of data value. For example, scatter plot, bar chart. If you take scatter plot, if I positioning the data point here, it is one magnitude. If you are positioning up somewhat upper point, it is a large magnitude. Similarly, bar chart, based on the position of my data point, the magnitude can be represented. So position encoding allows precise comparisons among the data values. Second property of visual is length. So again, it is for quantitative comparison or ordering purpose. It is very well used. The length property is very well used in bar chart. You can see that if it is higher the length, the magnitude of the data is higher. Lower the length, the magnitude of the data is less. So comparing to positioning, length can be accurately compared, making it effective for showing the difference in the magnitude. So you want to show the difference in the magnitude effectively to the human eye, length is the appropriate encoding method. Angle. When I try to show a part of contribution in a whole data set or the magnitude of the particular element compared to the other element in the data set, then we can use angle. Especially we are using this angle kind of encoding to show a part of contribution in the whole things in pie chart. You take pie chart, you see that how much angle of things I am putting. Based on that, the magnitude of the data element I can show. Lesser the angle, lesser the proportion of contribution in the whole data set. So that is the idea here, pie chart. Angles are useful for showing proportion within a world, although they are less precise than length. But you can see that why it is called less precise length means in visual, length easily capture the magnitude difference, but in angle, it is somewhat difficult to compare the magnitude angle, especially when you are going large number of elements in the pie chart. If the number of elements in the pie chart is less, fine. If you are going large number of elements, it is not advisable to use large number of element in the pie chart. If you are having large number of element, you can go for one or more pie charts rather than stacking all the element in the single pie chart. Then area. It is again for quantity comparison. Areas are used in the bubble chart and tree maps. For example, let us see the bubble chart here. So you can see the bubble size is more than the magnitude is high. So how much area covers the bubble, based on that the magnitude of the data is represented. The area is actually represented the data value, but humans are less accurate at comparing areas than length and position. So you can see that comparative purpose, if you put a lot of buffles with the different sizes, it is very difficult for human eye to compare it, comparing to that of length or position. And next element is color, especially hue value of color. It is used for categorical data, as we are already discussed. It is used in categorical heat maps, segmented bar chart. Heat map, you can see that by varying the hue value of color, I can represent the different magnitude of the data. But the hue is not suitable representing order or quantitative data, that you have to note down. And color again, but here this time saturation and lightness. It is best for quantitative data for highlighting purpose. So I can use the saturation lightness of the color property to give the highlights. It is used again in heat maps, glow plant maps. The variance in saturation and lightness can able to show intensity or magnitude, but can hard to compare accurately. That is another part. Texture, again, for it is used for categorical data. Pattern in bar or line chart can be given in a structure, but it is less effective comparing that of color and other elements. Safe, best for categorical data. For example, scatter plot with the different markers used for differentiate different element in the data set. Different shape can be represent different category, making it is easy to distinguish. So when you are going scatter plot, we are putting all the points over a area, but which data point belongs to which type of categorical data is very difficult to understand. So if you want to distinguish those, you have to use different shapes. For example, one category I can give rectangular shape of data points, another one is diamond shape, and the third one is star. Like that, different shapes I can use to represent different category of the data, especially when you are going scatter plot. Size, it is for quantitative comparison. Bubble chart, we already discussed that. Bubble chart, we are using different size of bubbles for represent different magnitude of the data. They are difficult to comparative purpose, especially we are going a large set of data types or data elements. Then finally, orientation. Again, it is best for categorical data or show the difference. Line chart with varied line style is the one best example for orientation. For example, if the lines are oriented upper direction, it is magnitude increasing, some lower direction, or orientation magnitude is decreasing, like that. Some differences, especially in the categorical data, we can show that orientation difference can help distinguish category, but not effective or precise quantitative comparison.